Our planet holds stories etched in stone, whispers from a time long before our own. These are not mere rocks, but the very remnants of life itself, preserved through unimaginable spans of time, waiting patiently for discovery. They are the keys that unlock the grand, sprawling narrative of evolution, revealing chapters of life's history that would otherwise be lost to us forever. Each fossil is a puzzle piece, a snapshot of a creature that once breathed, hunted, and roamed a world both alien and strangely familiar. To hold one is to touch the distant past. Today I invite you to join me, to unearth the secrets of our planet's ancient past. We will journey back through the eons, guided by the silent testimony of these extraordinary relics. Together we will explore not just bones but the revolutionary ideas they sparked, the scientific dogmas they shattered, and the new worlds they revealed to the human imagination. This is a story of discovery, of wonder, and of our own deepening connection to the immense tapestry of life that has unfolded on Earth. Prepare for a captivating journey through 10 groundbreaking fossil discoveries that forever altered our understanding of life's history. From the first giant reptiles that stalked the land to the delicate impressions of the earliest complex creatures, each of these finds represents a pivotal moment in science. They are the cornerstones upon which our knowledge of the prehistoric world is built. Let us begin our exploration into the depths of time, where giants once walked and the seas teemed with wonders beyond our wildest dreams. Our journey begins in 17th century England, a time when the world was thought to be young and its history neatly chronicled. It was here that a piece of a femur, colossal and utterly perplexing, was unearthed. So large was this bone that it defied all explanation. Some believed it belonged to a war elephant brought by the Romans, others whispered of biblical giants. The truth, however, was far more astonishing than anyone could have conceived. This was not a remnant of any known creature, it was a clue to a forgotten age. Decades passed and more of these strange, giant bones began to surface. It was not until 1824 that the geologist and paleontologist William Buckland gave this creature a name, Megalosaurus, meaning great lizard. He painstakingly described it as a gigantic, predatory reptile unlike anything alive today. This was a revolutionary act. The very idea of extinction was still a contentious theory, and the concept of creatures existing and disappearing long before humanity was deeply unsettling to the established order. Megalosaurus was the first challenge to that worldview. The discovery forced a profound shift in scientific thought. It was the first non-avian dinosaur to be formally named, planting the seed for a whole new field of study, paleontology. The Megalosaurus bone was more than just a fossil. It was the key that unlocked the door to deep time, the immense, almost incomprehensible expanse of Earth's history. It shattered the comforting illusion of a static, unchanging world, and replaced it with a dynamic, ever-evolving one. Suddenly, the ground beneath people's feet was not just soil and rock but a library of ancient life. The implications were staggering. If a creature as mighty as the Megalosaurus could exist and then vanish completely, what other marvels and monsters might lie buried, awaiting discovery? The world was older, stranger, and infinitely more complex than previously imagined. It ignited a dinosaur rush, a fervent quest to find more of these incredible prehistoric beasts. And so this single enigmatic bone from Oxfordshire became the first ambassador from a lost world. It taught us that our own time is but a fleeting moment in the grand saga of life. It demanded that we look back, not just thousands, but millions of years, and confront the reality of a planet ruled by creatures of a scale and nature that beggared belief. The age of dinosaurs had begun, not in the Mesozoic, but in the minds of 19th century scientists. In the limestone quarries of Solnhofen, Germany in 1861, a discovery was made that would send shockwaves through the scientific community. It was a fossil of exquisite detail, a creature no bigger than a modern magpie. But this was no ordinary bird. It possessed a curious and revelatory mix of features. It had beautifully preserved feathers, arranged on its wings as if for flight, yet it also had a jaw filled with sharp teeth, a long bony tail, and claws on its forelimbs. It was a perfect mosaic of reptile and bird. This creature, named Archaeopteryx, arrived at a pivotal moment. Charles Darwin had published On the Origin of Species just 2 years earlier, proposing the theory of evolution by natural selection, and predicting the existence of transitional fossils, intermediate forms that would bridge the gaps between major groups of animals. His detractors demanded proof. And Archaeopteryx seemed to be the answer, delivered directly from the rock. It was the missing link made manifest. Here was undeniable evidence of a creature caught in the midst of an evolutionary leap. Its reptilian skeleton, so similar to that of small dinosaurs, was a clear echo of its ancestry. Yet its feathers, the quintessential feature of birds, pointed towards its future. It provided the first solid, tangible proof that birds had not simply appeared, fully formed, but had evolved from reptilian, specifically dinosaurian ancestors. It was a stunning confirmation of Darwin's theory. The implications were profound. Archaeopteryx demonstrated that evolution was not a simple linear ladder but a complex, branching tree. It showed how features could be repurposed, scales fraying into feathers, forelimbs elongating into wings. This one small fossil opened up a whole new line of inquiry into the origins of flight and the intricate relationships between different animal groups. It painted a vivid picture of a Jurassic world, where the ancestors of today's songbirds still bore the teeth and claws of their dinosaurian kin. Even today, Archaeopteryx remains one of the most famous and important fossils ever found. It is a symbol of transition, a testament to the power of evolution to craft new forms from old. It is the ancient ancestor that connects the fearsome Tyrannosaurus rex to the humble sparrow in your garden. Every time we watch a bird take flight, we are witnessing the legacy of a journey that began over 150 million years ago, a journey beautifully and irrefutably captured in the limestone of Germany. Our story now takes us to the sun-scorched plains of Hadar, Ethiopia. In 1974, a team of paleoanthropologists led by Donald Johanson stumbled upon something that would forever change the story of our own origins. It was not a giant reptile or a feathered dinosaur, but the partial skeleton of a small female hominin who had lived 3.2 million years ago. As the team celebrated their find, the Beatles' song "Lucy in the Sky with Diamonds" played on their camp radio, and so she was given her name, Lucy. Lucy was a revelation. Her skeleton, though only 40% complete, was one of the most complete of her kind ever found. It belonged to a new species, Australopithecus afarensis. What made her so utterly spectacular was her combination of features. Her long arms and curved fingers suggested she was still comfortable in the trees, much like her ape-like ancestors. But the structure of her pelvis, her knee, and her thigh bone told a different, revolutionary story. These bones provided unequivocal evidence that Lucy walked upright. Her bipedalism was not a hesitant shuffle, it was her primary mode of locomotion. This was a monumental discovery. It proved that one of the defining traits of being human, walking on two legs, evolved millions of years before the dramatic increase in brain size that would later characterize our genus, Homo. We stood up long before we became the tool-making, large-brained creatures we are today. Lucy became a beacon, illuminating a crucial chapter in the human evolutionary saga. She was a member of a species that was, in many ways, the perfect transitional form between our more ape-like ancestors and later hominins. She provided a tangible face and form to what had previously been theoretical. No longer were our ancient relatives abstract concepts. Here was an individual, a small female who walked the African landscape over 3 million years ago. Her discovery reshaped the family tree of humankind. It demonstrated that our evolution was not a straight line from ape to human, but a bushy, branching process with many dead ends and side branches. Lucy stands as a matriarch of our deep past, a powerful reminder of our African origins and our profound connection to the natural world. She is, in a very real sense, a common ancestor, a grandmother to us all, whose fossilized bones tell the foundational story of what it means to be human. For centuries, one of the greatest mysteries in the story of life was how vertebrates made the momentous transition from water to land. There was this vast 30-million-year gap in the fossil record between lobe-finned fish and the first true amphibians. Scientists knew this transition must have happened, but the evidence remained, well, elusive. That all changed in 2004 on Ellesmere Island in the Canadian Arctic, a place that, believe it or not, was once a warm subtropical river delta. A team led by paleontologist Neil Shubin, acting on a prediction of where such a fossil might be found, discovered exactly what they were looking for. They named it Tiktaalik, an Inuit word for a large freshwater fish. It was a creature from the late Devonian period around 375 million years ago, and it was the perfect intermediate form. Tiktaalik had the gills, scales, and fins of a fish, but it also possessed features that were startlingly land-like. Its skull was flattened, like that of an early amphibian with eyes on top, just perfect for peeking above the water's surface. Crucially, it had a mobile neck, something no fish possesses, allowing it to turn its head independently of its body, a vital adaptation for looking for predators or prey on land. But the most stunning discovery was hidden inside its pectoral fins. Here were the beginnings of a wrist, an elbow, and a shoulder. These were not just fins for paddling, they were proto-limbs. The bone structure was homologous to that of all four-limbed vertebrates, including us. Tiktaalik could do a push-up, it could prop itself up in the shallows and perhaps even haul itself out of the water for short periods. It was a fishapod, a creature perfectly poised on the cusp of a new world, embodying the very moment of transition from an aquatic to a terrestrial existence. The discovery of Tiktaalik was a triumph of predictive science and a beautiful illustration of evolution in action. It filled the gap in the fossil record with breathtaking precision. It showed how existing structures like fins could be modified and adapted for entirely new purposes, paving the way for the eventual conquest of the continents by vertebrates. Every step we take on land is owed to the pioneering journey of creatures like Tiktaalik, which first pushed its head above the water and began to explore the shore. Long before the term dinosaur was even coined, strange, tooth-like fossils were being found in the fields of Sussex, England. In 1822, Mary Ann Mantell, wife of geologist Gideon Mantell, discovered these peculiar specimens. Gideon Mantell, an astute observer, noticed their resemblance to the teeth of an iguana, albeit vastly larger. He hypothesized they belonged to a colossal extinct herbivorous reptile, which he named Iguanodon, meaning iguana tooth. Mantell's Iguanodon was the second dinosaur ever to be formally named, after Megalosaurus, and its discovery helped to solidify the revolutionary idea of a prehistoric age of reptiles. However, the initial reconstructions were largely guesswork. Based on the limited material, Mantell and other artists depicted Iguanodon as a lumbering rhinoceros-like quadruped with a horn on its nose, a placement based on a conical bone found with the fossils. This image, though inaccurate, captured the public's imagination. The true appearance of Iguanodon remained a puzzle until a spectacular discovery in 1878. In a coal mine in Bernissar, Belgium, a treasure trove was unearthed, the complete skeletons of at least 38 Iguanodon individuals that had fallen into a deep ravine and perished. This was a paleontological jackpot. It allowed scientists for the first time to assemble a complete and accurate picture of this remarkable animal. The Belgian skeletons revealed that Iguanodon was not a lumbering quadruped but was capable of walking on its powerful hind legs. And the mysterious nose horn? The complete skeleton showed it was, in fact, a distinctive conical thumb spike. This unique adaptation was likely a formidable defensive weapon against predators, a tool for breaking into tough vegetation, or perhaps used in disputes with other iguanodons. The Bernissar find completely revised our understanding of this dinosaur. The story of Iguanodon is a perfect example of how science corrects itself. It showcases the journey from a few enigmatic teeth to a complete, dynamic vision of a living creature. The discovery of the Bernissar herd not only gave us a true picture of Iguanodon's anatomy, but also provided insights into its potential social behavior, suggesting they may have lived in groups. It remains a cornerstone of dinosaur paleontology, a testament to the power of new evidence to reshape our vision of the past. For much of the 19th century, dinosaurs were imagined as slow, sluggish, lizard-like beasts, dragging their tails on the ground. This perception was about to be turned on its head by a discovery in Haddonfield, New Jersey in 1858. Here, in a marl pit, workers uncovered the partial skeleton of a large dinosaur. It was acquired by the naturalist Joseph Leidy, who named it Hadrosaurus foulkii, the bulky lizard of Foulk. Though incomplete, the Hadrosaurus skeleton was the most complete found anywhere in the world at that time. What was truly significant was the disparity in size between its limbs. The hind legs were massive and powerful, while the forelimbs were much shorter and more slender. Leidy correctly deduced from this anatomy that Hadrosaurus was not a plodding quadruped like the Iguanodon was then thought to be. Instead, it was bipedal, walking on its two back legs like a gigantic bird. This was a radical idea. Leidy's reconstruction, brought to life by the artist Benjamin Waterhouse Hawkins, resulted in the world's first mounted dinosaur skeleton, put on display at the Academy of Natural Sciences in Philadelphia. It was a sensation. For the first time, the public could gaze upon a dinosaur that stood upright, active and dynamic. It directly challenged the prevailing view of dinosaurs as overgrown lizards and presented them as far more athletic and interesting creatures. Hadrosaurus became the prototype for an entire family of dinosaurs, the Hadrosauridae, commonly known as the duck-billed dinosaurs, due to the shape of their snout. These were some of the most successful and common herbivores of the late Cretaceous. The discovery of Hadrosaurus foulkes effectively launched dinosaur paleontology in North America, and set a new standard for how these animals were studied and displayed. The legacy of this New Jersey dinosaur is immense. It shifted the scientific and public perception of dinosaurs from lethargic reptiles to active, energetic animals. It demonstrated the importance of skeletal mechanics in understanding posture and locomotion. The dynamic pose of the Hadrosaurus mount inspired generations of paleontologists and captured the imagination of millions, proving that even a partial skeleton can spark a revolution in our understanding of a long-lost world. So, the late 19th century was known as the Bone Wars era in America, and honestly, it was a time of fierce rivalry between paleontologists Othniel Charles Marsh and Edward Drinker Cope. It was this wild period of frantic discovery, and from the Morrison Formation out in the American West, skeletons of an almost unbelievable scale began to emerge. Among the most magnificent was Diplodocus, the so-called double beam, which Marsh named in 1878 for those unique paired chevron bones on the underside of its tail. Diplodocus was a sauropod, a member of that group of long-necked, long-tailed plant-eating dinosaurs, but it really pushed the limits of terrestrial life to their absolute extreme. I mean, stretching up to 90 feet or about 27 meters from head to tail, and honestly, most of that length was its incredibly long neck and an even longer, whip-like tail. For decades, Diplodocus was celebrated as the longest animal ever known to have walked the Earth, and its sheer size was, and still is, a source of profound wonder. The discovery of nearly complete Diplodocus skeletons allowed scientists to really dig into sauropod anatomy. Its peg-like teeth, which were all concentrated at the front of its mouth, suggest it was a pretty selective browser, likely stripping leaves from branches. And those complex bird-like air sacs inside its vertebrae? They helped lighten its enormous frame without sacrificing strength. Its posture, which people once thought was kind of swamp-bound and sprawling, is now understood to be fully terrestrial, with a horizontal neck and a tail held high off the ground as a counterbalance. The fame of Diplodocus spread far beyond scientific circles, thanks in large part to the industrialist Andrew Carnegie. After seeing an illustration, he funded expeditions to find a complete skeleton, and then get this, he commissioned numerous plaster casts of the magnificent specimen, Dippy. These casts were donated to museums all over the world, from London to Paris to St. Petersburg, making Diplodocus the first dinosaur to become a truly international celebrity and really a global ambassador for the prehistoric world. Diplodocus forces us to grapple with the biology of the gigantic. How did an animal this large function? How did it pump blood all the way to its head? How did it breathe? And just how much did it have to eat each day? These are the kinds of questions that continue to drive research and challenge our understanding of biological and physical limits. Diplodocus isn't just a fossil, it's an icon of scale, a testament to a time when life on land reached its most colossal proportions, shaking the very ground with every single step. Our understanding of dinosaur behavior is often limited, pieced together from indirect clues. But, a single fossil site in New Mexico called Ghost Ranch provided an unprecedented window into the lives of one of the earliest dinosaurs. In 1947, paleontologists uncovered a graveyard containing hundreds upon hundreds of skeletons of a small, agile carnivore named Coelophysis, which lived during the late Triassic period. The sheer number of individuals found together was extraordinary. The fossils were all jumbled together, ranging from young juveniles to fully grown adults, all seemingly having perished in a single event, maybe a flash flood that trapped them in a riverbed. This mass mortality assemblage was a paleontological treasure. It wasn't just a single specimen, it was a snapshot of a population, a census of a species frozen in time. The Ghost Ranch quarry allowed for a detailed study of Coelophysis anatomy and variation. With so many specimens, scientists could analyze growth stages from hatchling to adult, and even observe potential differences between males and females. The light, hollow-boned skeleton, characteristic of later theropods, confirmed that even the earliest dinosaurs were fast and agile predators, far from the lumbering beasts of earlier imagination. But the most tantalizing insight from Ghost Ranch was behavioral. Finding so many animals of different ages together strongly suggests that Coelophysis was a social animal. They likely lived and hunted in packs. This discovery fundamentally altered our view of early dinosaurs. They were not just solitary monsters but complex creatures with social structures, perhaps cooperating to bring down larger prey or for mutual protection. The image of a pack of Coelophysis moving through the Triassic landscape is a powerful one. Furthermore, some of the adult skeletons contain the bones of smaller Coelophysis within their rib cages, leading to the controversial but compelling theory of cannibalism. Whether this was opportunistic scavenging or active predation, it adds another layer of complexity to their behavior. The Ghost Ranch fossils transformed Coelophysis from a simple predator into a deeply understood animal, offering one of our clearest glimpses into the social dynamics and harsh realities of life in the Triassic. No dinosaur captures the imagination quite like Tyrannosaurus rex. Its name alone, the Tyrant Lizard King, evokes an image of unmatched power and ferocity. Since the first partial skeleton was discovered in 1902 by Barnum Brown, T-Rex has reigned supreme in both popular culture and scientific interest. But honestly, beyond its fearsome reputation lies a fossil that has provided a wealth of information about the pinnacle of dinosaur evolution. T-Rex was one of the last and largest terrestrial carnivores of all time. Its massive skull, up to 5 feet long, was not just for show, it was a biological weapon of immense power. Studies of its structure reveal it was built to withstand enormous stress, housing powerful jaw muscles that delivered the strongest bite force of any land animal ever estimated. Its huge, serrated, banana-sized teeth were not for slicing, but for crushing bone. It was an apex predator of terrifying efficiency. Despite its fame, T-Rex has been a creature of scientific debate. Were its tiny, two-fingered arms useless vestiges, or were they muscular and used for grasping prey at close quarters? Was it a swift hunter, or a slow-moving scavenger? The discovery of more complete skeletons, including Sue and Stan, has helped answer some of these questions. Evidence from healed bite marks on other dinosaur fossils confirms it was an active predator, while its large olfactory bulbs suggest a superb sense of smell, useful for both hunting and finding carcasses. The study of T-Rex fossils has also been at the forefront of paleontological technology. The discovery of soft tissue and possible blood cell remnants inside a T-Rex femur by Dr. Mary Schweitzer opened up the revolutionary field of molecular paleontology. While we are a very long way from cloning a dinosaur, these findings provide a tantalizing link between these ancient beasts and modern birds, their closest living relatives, on a cellular and molecular level. Tyrannosaurus rex is more than just a monster from a bygone age. It is a superb case study in biomechanics, predatory ecology, and the limits of evolution. Each new fossil teaches us more about its life, its growth from a turkey-sized juvenile to a 9-ton adult, and the world it dominated. It remains the ultimate dinosaur, a perfect combination of celebrity status and profound scientific importance, the undisputed king of the Cretaceous. Our final journey takes us high into the Canadian Rockies, to a modest quarry known as the Burgess Shale. The fossils found here are not the giant bones of dinosaurs, but small, often bizarre and exquisitely preserved impressions of soft-bodied creatures from the Cambrian period, over 500 million years ago. Discovered by Charles Doolittle Walcott in 1909, this site contains a snapshot of the immediate aftermath of the Cambrian explosion, a period of rapid evolutionary diversification. The preservation at Burgess Shale is honestly miraculous. The fine-grained mudstone captured not just shells and hard parts, but the delicate details of antennae, gills, and internal organs of creatures that would normally leave no trace. This opened a window into a world of life that was previously invisible. The fauna it revealed was astonishing, a menagerie of organisms so strange they seemed to be from another planet. There was the five-eyed Opabinia with its frontal nozzle, the spiny hallucigenia that for decades was reconstructed upside down, and the formidable predator Anomalocaris. The Burgess Shale fossils fundamentally challenged our understanding of the Tree of Life. Initially, scientists tried to shoehorn these strange creatures into existing animal groups, but it became clear that many of them represented entirely new body plans, evolutionary experiments that ultimately led to dead ends. It suggested that the history of life was not a predictable march of progress, but a chaotic lottery, where chance and contingency played a huge role in determining which body plans survived to produce the diversity we see today. This weird wonderland showed that the Cambrian seas were far more diverse and complex than anyone had imagined. It revealed the early origins of major animal groups, including the phylum to which we belong, Chordata, represented by the small, fish-like creature, Pikaia. The Burgess Shale provides the foundational evidence for the explosive burst of creativity from which all subsequent animal life evolved. The importance of this single fossil locality cannot be overstated. It is a Rosetta Stone for understanding early animal evolution. It teaches us that the world we inhabit and the forms of life that fill it were not inevitable. They are the survivors of a grand, unpredictable experiment that took place 500 million years ago. The silent, flattened creatures of the Burgess Shale tell one of the most profound stories in all of science, the story of our own most distant origins. From the first-named dinosaur to the ghostly imprints of the Cambrian Sea, these 10 discoveries are far more than just relics. They are narrative threads, woven together to form the epic tapestry of life on Earth. They have challenged our perceptions, reshaped scientific paradigms, and expanded our sense of time and our place within it. Each fossil was a revolution, a moment when the story of our planet took a sudden, dramatic turn, revealing a past more wondrous and complex than we had ever dared to imagine. The ground beneath our feet is a library, and its volumes are still being written and discovered. The work of paleontologists continues in the frozen Arctic, the scorching deserts, and the high mountains. With every new find, a new chapter is added, a new question is asked, and our connection to these ancient worlds deepens. The story of life is a story of constant change, of extinction and innovation, and it is a story that includes us all, for we are the products of this immense and beautiful history. This has been but a glimpse into the treasures that our planet holds. The quest to understand our past is a journey without end, fueled by curiosity and the profound wonder of discovery. Like and share if you enjoyed this voyage through time, and may you always look at the world around you with a sense of the deep, incredible history that lies just beneath the surface, waiting to be unearthed.